So we've just talked about a plane and a line intersecting each other. Well, we've talked before about two lines intersecting each other. So why wouldn't we talk about two planes intersecting each other? So how can we check whether two planes are going to intersect? Well, first let's think about what are the possibilities. Well, we can either have two parallel planes, one sitting right on top of the other, or if they're not parallel, just like in the case of two lines in the xy plane, the two planes are going to have to intersect. So how do we check if two planes are parallel? Well, let's write down two equations for a plane. All right, so we have, let's say the first plane, let's call it pi 1, is given by a1 x plus b1 y plus, not b, sorry, c1 z is d1. And let's say we have another plane, pi 2, that's given by a2x plus b2y plus c2z is d2. So how can we check if these two planes here are parallel? Well, remember, two lines are parallel if they have the same direction. Right? For planes, the thing that takes the place of direction is the perpendicular direction. So if these two planes have the same perpendicular direction, then the planes must also be parallel. Well, to do that, we need to find the perpendicular direction, or the normal vector for each of these planes. So for here, the normal vector, let's call it n1. Remember how we constructed the plane? The components of the normal vector ended up just being the coefficients of x, y, and z in the equation of the plane. Right? So that means the normal vector is a1, b1, c1 for the first plane. Right? Okay, so what about the second plane? Well, again, we just read off the coefficients. a2, b2, c2. So these are the normal directions for each of these planes. Well, if they're going to have the same normal direction, all that matters is, are these vectors parallel? So pi 1 is parallel to pi 2 if n1 is parallel to n2. Simple as that. So we just have to check whether the normal directions are parallel.